Okay. So, hey, hello. Welcome to this presentation. I'm Mohammed Aliasgar, and yeah, I'm going to be presenting two different software disasters. Before we begin, I'd like to mention that this presentation is 100% organic, human-made. I did not use any AI, I promise. Okay. Yeah. First on the list is a little machine called Therac 25, which was used in the 1980s for treating cancer patients with radiation therapy. And yes, so some essential points about this machine: it was controlled by a single terminal-like interface by one person with no hardware interlocks like its predecessors that were Therac 6 and Therac 20. It was made by a single developer over a period of several years, and it was not subject to rigorous testing in terms of software and hardware before it hit production. That's the hospitals. So you can clearly guess where this is going. It's like a prime scenario for a disaster to happen, and that's exactly what did occur. So what went wrong, essentially, right? What was the exact problem? I won't go into the specifics, but here's an overview. So essentially, it involves a very classical computer science problem that is faced by multi-threaded programs, which is the race condition, right? Race conditions. Okay, so the short of it is that the variables for the display, okay, the data entry display, as well as the background job for the keyboard handler shared the same storage variable. Okay, that meant that it was well a scenario for a race condition. So when they both tried to access the same variable, it meant that they could change it unpredictably, depending on which one of them got there first. Yes, so this would essentially mean that in a scenario where there's a quick fingered typist, okay, working as a therapist there, they could accidentally, in trying to correct one of the mistakes, set the radiation administration to the lethal dosage rather than the normal advised one. And that's exactly what happened to many people. It's 6 people died due to this flaw, and this happened over a span of 1 to 2 years before it was actually investigated and reported. Quite sad. 6 people died. Two to three in 1985, two in 1986, and one in 1987 in Japan. Uh, this this is the machine over here. This is what it looked like. Okay, Thrack 25. So on to the next segment. What are the takeaways? So first of all, malfunction 54 is not a descriptive error. Okay, it had with no technical documentation or reference and with no reliable method of contacting the developer, malfunction 24 does not suffice as a good enough explanation of what went wrong. So, good error messages are very essential. Second, reliable software is not safe always. So if something worked in the past and you think it may work in the future, it's not a compulsory thing. It's not a given. It may break. There can be discrepancies between the hardware and the software. Many things could go wrong. So constant testing should be a requirement in critical software infrastructure, like for example train systems, hospitals, etc. Third is inadequate investigation of incidents and follow-up reports is not good. Okay, if anything occurs, at least software parties and the people concerned should investigate it in detail so as to avoid something similar in the future. Okay. And there's also a personal point that I would like to mention, that safe user interface versus precise user interface, friendly user interface, and the precise one. There's a lot of sacrifice if you want to make something user friendly rather than precise. And in critical software infrastructure, precision is key. You need to be able to set values very precisely with fine control over the hardware and the software. So one of the potential things that happened in this incident was that the developer was trying to abstract the complexities of the system away from the technician so that they could just operate it normally, but that meant giving up much of the precision that the predecessors had. Okay, next is the fact that zero trust software policy is not something that's like the end all be all. It's not the only solution to this. There's a lot more that goes into actually making software more usable and more safe. So developers cannot just be like, yeah, well, I don't trust the user, I don't trust the computer, I'll just make it so that it's completely foolproof. No, that does not happen. Okay, there's always human errors, there's always errors that are unaccountable for, right, and that cannot be predicted. So the only solution to this is to constantly test software and check it from time to time for any errors, any update, security vulnerabilities, etc. So that's it for the Therac 25 incident. Now on to the next one. Okay, so this one is a bit of a more recent incident, not as recent as another one that's related to this, but this happened on 31st of January 2017 at the GitLab headquarters, and essentially I'm enumerating many points over here, so you're free to check them, but I'll give a short summary. So what happened was that an employee with unchecked policy administration access was able to run an untested command on a production server instead of a testing environment, accidentally of course, and they ended up deleting the primary database, or a section of it at least, the full production database, on accident, and it resulted in over almost about over 300 gigabytes of data lost in repositories, projects, issues, pull requests, many change logs. So it affected the open source community quite a bit, and essentially the entire situation was just a bunch of mismanagement in user access and a lot of failures and subpar recovery systems and backup systems. So let's have a look at the analysis. Okay, so what the hell went wrong? First of all, an employee had access to production environment and they were able to run untested commands on there. That should not happen. All employees should at least have to review or have to peer check what they're trying to do on a production server, because it's critical. It's the main thing that they're using. Okay. Second is hard deletion of data. So essentially, the production database should not employ hard deletion of data, either customer data, employee data. It should employ something called soft deletion, which is that the data to be deleted is marked and it is slowly deleted over time by a background process. So if there is an accidental input of a command that deletes everything, that can be cancelled and with little to no repercussions. Third, there was lack of testing of recovery systems. So essentially the secondary database was not updated in a timely manner, so it did not contain a lot of what was lost. Okay. Third is that the critical reports about this were not announced to all developers and employees, which is quite bad, because if the employees and the developers are not updated about what the company is about and what they're doing and the problems with their environments, then they cannot act according to the best security policies and the best production policies. And last of all, there was no secondary recovery plans. So in case the second database server also failed, they could have a fallback plan. And here are some of the fixes that they could have employed. First, strict policies about what employees can or cannot do on production servers and even testing servers. Okay, access rights and user access rights and whatnot. Second, obviously, employ soft deletion of data rather than hard deletion. It's quite good to have that. Third, regular testing of recovery systems and databases. Fourth, announce the error reports to developers. The company should keep its employees informed. Fourth, development testing of secondary recovery systems is quite important in case the primary recovery systems fail. Okay, so what's the takeaway from all of these? Do not trust humans and computers in any measure. Well, actually, no. You must, essentially, the takeaway is that many companies fail at employing good testing policies for systems before they allow access of it to employees, and they increase the scope of it and provided abilities to do more. Okay, and well, that's that. Thank you for watching the presentation. Once again, I will mention all the references I've used in a separate document. And thanks once again. Thank you.